Hello everyone, welcome to my YouTube channel Crack Economics and Statistics. This is Atman Shah. I teach economics at St. Xavier's College, Ahmedabad, India. The theme of today's webinar or YouTube live session is all t-tests using RStudio. So we are going to cover one sample t-test, independent samples t-test and pair t-test, how to perform these tests in RStudio and how to interpret the result. We have conducted the webinars on all t-tests using SPSS, ANOVA using SPSS, factor analysis, cluster analysis, correlation analysis. So we conducted the webinars on Carl Pearson's correlation, Spearman's rank correlation, and regression analysis using SPSS. You can find the link of all these webinars in the description. You can also find videos on SPSS, R programming, economics, and statistics on our YouTube channel. So I request everyone to subscribe to our YouTube channel, Crack Economics and Statistics, to find more videos on these topics. So today I'm going to cover the theory of each t-test. So we are going to first understand the theory. Then I'm going to show you how to perform the t-test in RStudio. And then I'll explain the interpretation of the result. Since this is a live session, you can also ask the questions. So if you have any doubts, if you have any queries, you can write your queries in the live chat box. I will take the questions after completing each test. And I request all of you to stick to the theme of the webinar while you ask the questions in the live chat box. So let's begin today's session. The t-statistic was introduced in 1908 by William Seeley Gossett, and he published his work under the pseudonym of Student. And that is why it is also known as student t-test. There are three types of t-test. First is one sample t-test. Second is paired t-test. And third is independent t-test. So today we are going to cover all these three t-tests, the theory, the logic behind these three t-tests, and the command which are used to perform these t-tests in R programming and their interpretation as well. Now, what are the assumptions? The first assumption is the sample size should be small. Now, normally, we say that if the sample size is less than 30, it is considered to be a small sample, and if it is higher than 30, it is considered to be a large sample. But if you have large sample and if all other assumptions are fulfilled, you can still use t-test. Second, the sample should be collected randomly. So random sampling is required to perform the t-tests. The population should be normally distributed, which means that all t-tests are parametric. All t-tests are parametric because normality assumption is required to perform t-tests. Fourth, the selection of observations should be independent of each other. Fifth, the variance of the population should be known. And sixth assumption, the data must be an interval or ratio scale, which means that we need a quantitative data, a continuous data to perform all t-tests. Since these two assumptions are required, all t-tests are parametric. So if we have nominal or ordinal data, we cannot perform t-test. These assumptions are common for all types of t-test. So I'm not going to explain the assumptions again when we discuss the types of t-test. So these are common assumptions which are required to perform the t-test. Let's begin with the one sample t-test. So one sample t-test is used to compare the sample mean with given population mean or a given value. So here we are interested to compare the sample mean with a population mean or a given value. It is used to determine whether the sample is generated from a specific mean. Let's take an example to understand the usefulness of one sample t-test. Suppose a researcher claims that the consumption expenditure of male is higher than the national average. Now we want to test this, whether this statement is true or not. So to test this, we can collect the sample of males and compare the mean consumption expenditure of males. That is sample mean, and compare this sample mean with national average, which is a given population mean. You can see here the national average is given. So therefore, we can use one sample t test. So we use one sample t test when we want to compare the sample mean with given population mean. So step 1 is define the null and alternative hypothesis. Just a second. Define the null and alternative hypothesis. Now, what is null hypothesis in this case? There is no significant difference between a sample and the population mean. Here you can see no significant difference. So sample mean is X bar and population mean is mu. So both are same. X bar is equal to mu. Against the alternative hypothesis of a significant difference. There is a significant difference. So therefore we can write X bar is not equal to mu. So that is the null and alternative hypothesis in case of one sample t-test. Null hypothesis, no significant difference between a sample and population mean. Alternative hypothesis, there is a significant difference between sample and population mean. Now step 2, decide the level of significance. So normally it is 5%. So our alpha is equal to 0.05. Third, calculate t statistics by using following formula or perform the test in software. If you want to calculate t statistic manually, you can use this formula. But here we are going to see how to perform this in RStudio, so there is no need to calculate t statistic manually. Here you can see X bar is the sample mean, mu is the population mean, S is the sample standard deviation, and N is sample size. Step 4, interpret the result by using following arguments. So we reject the null hypothesis when P is less than alpha. The P value or the SIG value is less than alpha, then we reject the null hypothesis. And we fail to reject the null hypothesis when P value is greater than alpha. This is the decision rule and it is common for all statistical tests. Whether you are going to use parametric test or non-parametric test, these arguments are common. We reject the null hypothesis when P value is less than alpha. We fail to reject the null hypothesis when P value is greater than alpha. Now, what is the command which can be used in R to perform t-test? So you can note down this command. T.test is the command that can be used to perform all these t-tests. So T.test in bracket test variable, that is the variable that we want to test. Suppose we want to test the consumption expenditure of male. So here we can select consumption expenditure. Mu is the given population mean. mu is the given population mean. Alternative is equal to two-sided and confidence level is equal to 0.95. If you do not write this portion, this is the by default selection. If you do not write, the R takes it as two-sided and confidence level is equal to 0.95. So this is the command that we are going to use when we perform the t-test in RStudio. Now let me share the RStudio file. So here you can see R script and this is console. I have given the name data to the data that I have with me. Read.csv command is used to import the CSV file to R. File.choose, that is another command, and header is equal to true, which means that if you have the Excel file, the first row of that file shows the name of the variable. And you simply click on run, you can see the data in console. So let me show you the data first. This is our data file. You can see first column here that shows the ID. I have generated ID. So I have 30 observations with me. Second column shows the gender of the respondent. So we have male and female. So we have two categories in this variable. So gender is a nominal variable. Third column shows the faculty, whether that respondent comes from the arts faculty, commerce faculty, or science faculty. So you can see A stands for arts, C stands for commerce, and S stands for science. Fourth column shows the location of the respondent, whether the respondent stays at home, that is H, hostel, HT, and paying guest, P. So H stands for home, HT stands for hostel, and P stands for paying guest. Column INT shows the internal marks of the respondent. EXT shows the external marks of the respondent. And EXT1 shows the external mark of the respondents after conducting the remedial classes. So this is the data that we have. Now, before we start performing the t-test, we first need to check whether our data is normally distributed or not, because normal distribution is important to perform the t-test. Since we have only 30 observations, we can use Shapiro-Wilk test to check the normality of the data. So the command is Shapiro.test. Here you can write the name of the variable. So my data is labeled as data, that is the file. In data, I want to know whether external marks are normally distributed or not. So I use $sign and then you select external. So I want to know that the external marks are normally distributed or not. But this external marks is located in this data file. That is why I have written data $external. Simply click on run. You can see the output here. Shapiro-Wilk normality test. Our data set is data $external. The test statistic is 0.95414 and p-value is 0.218. So this value is higher than 0.05. The null hypothesis is data is normally distributed. An alternative hypothesis is data is not normally distributed. Since this p-value is higher than 0.05, we fail to reject the null hypothesis and we conclude that the data is normally distributed. So therefore, we can conduct or we can perform t-tests. Now I'm performing the Shapiro-Wilk test on external marks 1 to check whether that variable is normally distributed or not. So you use Shapiro.ttest data $ext1. Here you can see p-value is again higher than 0.05. So we fail to reject the null hypothesis and therefore we conclude that the data is normally distributed. So now we can perform one sample t-test. So I'm writing one sample t-test. So suppose I want to test whether this data is collected from the population having mean marks of 65, external marks. You can see this data. See, external marks are out of 70. So I want to check whether this data is collected from the mean marks of 70. So my given population, 65. So my given population mean is 65. So we use t.test command. Now you can write the variable name. So our variable is external marks, comma. That is our variable that we want to test. Mu is equal to 65. That is the given population mean. Right? Alternative is equal to two-sided and confidence dot level is equal to 0.95. You can omit this portion because this is the by default selection. If you want to change, you can mention. If you do not want to change anything, you can simply write these two values only. So click on run. You can see this one sample t-test output is generated in console. So our data is data.data$ext. T statistic is minus 9.8161. Degree of freedom is 29, that is n minus 1. So we have total 30 observations. So it is 30 minus 1, that is 29. Our p-value is less than 0.05. So therefore, we reject the null hypothesis. Now, what is the null hypothesis in this case? The sample mean is not equal to the sample mean is equal to the population mean, that is 65. So there is no significant difference between sample mean and population mean. What is the alternative hypothesis? There is a significant difference between sample and population mean. So sample mean is not equal to population mean. So here our population mean is 65. So you can see alternative hypothesis is written here. True mean is not equal to 65. Now since our p-value is less than 0.05, we reject the null hypothesis and we conclude that the sample mean is not 65. In other words, we can say that this sample is not taken from the population having mean marks of 65. You can see the mean of X, that is the mean of our variable is 41.06. That is the sample mean X bar. Now you change this value. Instead of 65, I'm writing 40. So again, I'm writing t.taste data $txt. And instead of 65, I'm writing 40. This is our command. Simply click on run and see this value. See this result. T value is 0.43749. Degree of freedom is 29. P value is now higher than 0.05. So we fail to reject the null hypothesis. And we conclude that this sample is taken from the population having mean marks of 40. You can see the alternative hypothesis here. So this is the idea of one sample t-test and its interpretation in RStudio. So if you have any questions, you can write in the live chat box regarding the one sample t-test, its theory and application in RStudio. So there are people from Nepal, Pakistan, Ahmedabad, Bangladesh. Welcome everyone. If you have any doubts, you can write the questions in live chat box. If you don't have any doubts, we can continue with the theory of paired t-test. Okay, so let's talk about paired t-test. A paired t-test is used to compare the two means which are from the same observations. So the variable is measured twice, which results in the pair of observations. You can see here we measure the variable at two different time periods. So we take the sample from the same observation at two different time periods. Let's understand it with the help of example. Suppose we want to check the effectiveness of remedial classes on the result. We want to check the effect of remedial classes on the result. So whether remedial classes are useful or whether remedial classes really improve the result of the students or not. So what we do, we can randomly collect a sample of result before and after the remedial classes. See this table. So we have student 1. From this student, we can collect the sample before remedial classes and after remedial classes. So here we collect the data from the same student at two different time periods, before something and after something. So before remedial classes and after remedial classes. So this makes a pair. This is pair 1. Similarly, we can collect the data from the second student before and after remedial classes. So that makes pair 2. From student 3, that makes pair 3. So here the observation in one sample is uniquely associated with the observation of other sample, and that is why we have a pair, and this test is known as paired t-test. Let's take another example. Suppose we want to check the effectiveness of the training program on the productivity of the employees, whether the training program increases the productivity of the employees or not. So again, we can randomly collect the sample of productivity before and after the training program. So we collect the data from the same employee before the training program and after the training program. So that makes a pair, and that is why this test is known as paired t-test. What is the null hypothesis in this case? There is no significant difference between the means of two paired groups. So mu1 is equal to mu2. There is no significant difference. Or the mean difference between two paired group is 0. Since these two are equal, the mean difference is 0. So you can write mu1 is equal minus mu2 is equal to 0. What is the alternative hypothesis? The means of two groups are significantly different. So mu1 is not equal to mu2. Or the mean difference between two paired groups is not 0. So here you can write mu1 minus mu2 is not equal to 0. So this is how we frame the null hypothesis in case of paired t-test. Step 2 is to decide the level of significance. So normally it is 5%. You can calculate t statistic with the help of this formula. So here you can see d is the distance between two paired groups. So suppose we have student 1 marks before remedial classes and marks after remedial classes. Suppose this is 65, 68. So the difference between these two is -3. That is our d. So here d bar shows the distance between two paired samples. S is the sample standard deviation and n is the sample size. So we can use this formula when we want to calculate it manually, but we use the command to perform this test in RStudio. So interpret the result by using these arguments. We reject the null hypothesis. If P is less than alpha, we fail to reject the null hypothesis. If P is greater than alpha. As I said earlier, these arguments are common. Now, what is the command to perform paired t-test in R? So again, t.test command is used. First, we write variable 1 or group 1. Second, we write variable 2, that is group 2. Paired is equal to t, that shows that these two variables are paired with each other. Alternative is equal to two-sided. Confidence dot level is equal to 0.95. So again, these two are default selection. There is no need to write these two if you do not want to change this. So this is the command that we are going to use when we want to perform the paired t-test in RStudio. So let me share my RStudio screen. So now we are going to discuss paired t-test. Paired t-test. So what is our command? It is t.test. Now before I perform, what we are going to test in this case. So see our data. Here we have external marks and external 1 marks. So this ext mark shows the marks before remedial classes and ext1 marks shows the marks after remedial classes. So here I want to compare or I want to check whether the remedial classes are useful or not. So you can see the observation before remedial classes, the marks before remedial classes is taken from this observation and marks after remedial classes is also taken from the same observation. So these two makes a pair, 65, 68. So in this case, our null hypothesis is there is no effect of remedial classes on the result of the students. So mu1, that is the mean of ext, is equal to mean of ext1. There is no significant difference, or there is no effect of remedial classes on the result. So I write t.taste. We first write the variable one. So our first variable is ext. So it is data $ext, comma data $ext1. So we have these two variables. Then we write pad is equal to true, that is t. So we are saying to this program that these two variables ext and ext1 are paired. You can write alternative is equal to two-sided and confidence dot level is equal to 0.95. So this is our command to perform pad t-test in R. So simply click on run. You can see the result of pad t-test in the console. This is our result. So first shows the data set, our two variables, variable ext and variable ext1. This shows the value of t statistic. It is minus 9.2759. Degree of freedom is 29, which is n minus 1. So 30 minus 1, which is equal to 29. P-value is less than 0.05. So we reject the null hypothesis. You can see the alternative hypothesis is written here. The two difference in means is not equal to 0, which means that the mean marks before remedial classes and after remedial classes are significantly different. So we have the significant effect of remedial classes on the result of the students. This is our confidence interval. And this shows the mean of the difference. What is the difference between mean marks before and after remedial classes? It is 8.966667. That is x1 bar minus x2 bar, or you can say d bar. So this is how we can perform the pad t-test. Now suppose you want to perform one-tailed, not two-sided, but one-sided. So here instead of two-sided, you can write greater than or greater or less. So I'm again using the same command, data $ext, data $ext1, pad is equal to t, alternative is equal to greater, and confidence dot level is equal to 0.95. Now instead of two-sided, I have written greater here. So simply click on run. Now you can see the alternative hypothesis is changed. It is two difference in means is greater than 0. And our p-value is equal to 1. So here what is our null hypothesis? The null hypothesis is the mean marks before remedial classes is lower than the mean marks of after remedial classes. So here you can see true difference in means is greater than 0. And since this p-value is higher than 0.05, we fail to reject the null hypothesis. And we conclude that the mean marks before remedial classes is less than the mean marks of after remedial classes. Now, instead of greater than, write less. So t dot paste, I'm pasting this. Now, instead of greater, you write less and click on run. So you see p-value is less than 0.05 because it is obvious that the mean marks after remedial classes is higher than the mean marks of before remedial classes. You can see this difference. So this is how you can change the command as per your requirement, whether you want the one-sided, one-tailed or two-tailed hypothesis testing. So if you have any doubts regarding the paired t-test, write in the comment. One question is how we will decide whether mu is equal to 65 or 40. See, you don't need to decide because in one sample t-test, the population mean is given. I have changed this to just show you that how result changes or how to interpret the result in case of rejecting the null hypothesis or failing to reject the null hypothesis. So here this 65 or 40 is given. You don't need to check. Let's take the example whether the sample is taken from the population having the literacy rate of 75. So that literacy rate of 75 is given and that is your population mean or a given value. Now you calculate the sample mean and compare that sample mean with given population mean, that is the 75. So you don't need to decide the population mean. The population mean is given to you. I hope I have cleared your doubt. So if you have any other doubts regarding the paired t-test, write in the live chat box. So now we are going to discuss the idea of independent samples t-test. So independent samples t-test is used to compare the two unrelated groups or unpaired groups. It is also known as unpaired groups. So here the observation in group 1 is not associated with observation in group 2. It does not make a pair. Two groups are completely independent of each other. Let me take one question from Ganesh Prasad Adhikari. If we choose the one class section A purposefully, can we take pair sample t-test? And other queries, we divide this group into two groups. As experiment and control, we use it. If we choose the one class section A purposefully, can we take pair sample t-test? Ganesh, can you please elaborate your question? I'm not getting it correctly. So if you have the paired groups, if two groups are related with each other, then we are going to use paired t-test. That is the basic idea, which means that the observations in group 1 are related with observations in group 2. So therefore they make a pair. So if you have two groups and two groups are associated with each other, or you are conducting the experiment and you are collecting the data from the same observation at two different time points, then again we have the paired groups. Now suppose you are collecting the data from husband and wife regarding their opinion whether they want to they want to put their children in vernacular medium school or English medium school. So now again husband and wife are paired group. They cannot be treated as independent groups. Suppose you are conducting the data or you are collecting the data from the twins. They make a pair. Right? Brother and sister make a pair. But basically, or in general, the paired t-test is used to, to find the effectiveness of something. So before something and after something, or before an event or after an event. That is the basic idea of paired t-test. On the other hand, we have independent t-test. Here also we have two groups, but these two groups are completely independent of each other. And that is why they are unpaired groups. You cannot make a pair. Let's take this example. Suppose we want to test whether the consumption expenditure of male and female students are significantly different or not. So here we have first group of male students and second group of female students. So they are not associated with each other. But suppose you want to find the effect of pandemic on consumption expenditure of the students. So you collect the sample of consumption expenditure before pandemic and consumption expenditure after pandemic from the same student. So that makes a pair. But here we have two different groups. I hope I have answered your question. So when we have two independent groups or unpaired groups, we are going to use independent t-test. The name itself suggests its usefulness. In paired t-test, we have paired group. In independent t-test, we have independent groups. So here we have two unrelated groups, male students and female students. One continuous variable, that is consumption expenditure. So first step is to define the null and alternative hypothesis. There is no significant difference between the population mean of two groups. Or mu1 is equal to mu2. Please keep in your mind that we are talking about two unrelated groups. In independent t-test, we have two independent groups. The alternative hypothesis is the population mean are significantly different. So mu1 is not equal to mu. Step 2 is to decide the level of significance. So in general, it is 0.05. Step 3, calculate t statistics by using the following formula. So here we have x1 bar is the mean of group 1 and x2 bar is mean of group 2. S is the sample standard deviation, N1 is the sample size of group 1 and S2 is the sample size of group 2. So we use this formula if we want to calculate the t statistic manually, and then we compare this t statistic with tabulated value. The arguments for the decision rule: reject the null hypothesis if p-value is less than alpha, and fail to reject the null hypothesis if p-value is greater than alpha. Now what is the command in R? Again, we use the same command t.test. Here we first write the variable that we want to test. Suppose we want to test consumption expenditure. So we select consumption expenditure and then we use our categorical variable, that is gender. Suppose we have that variable. Alternative is equal to two-sided, confidence level is equal to 0.95. So let's perform it in R. So now we are going to perform independent t-test. So t.test, that is our command. Data $ext. Now what is our categorical variable? It is gender. So I'm selecting gender. So here I want to know whether the marks of male and female students are significantly different or not. So we have two groups, male and female. Two groups are independent. So therefore we can go or we can use independent samples t-test. So this is our data, external, gender. Now before we use this t-test, we need to check whether the variances of these two groups are homogeneous or not. So before performing this test, let's check whether the variances are homogeneous or not. So for that, we have Bartlett test. So you write Bartlett.test. We want to know whether the variances of male and female group are same or not. So I write data $ext data $gender, and you simply click on run. You can see this test, Bartlett test of homogeneity of variance. In this case, the null hypothesis is variances are homogeneous, or there is no significant difference in the variances of two groups. You can see p-value is 0.4505. So therefore, we fail to reject the null hypothesis, and we conclude that variances are equal, or variances are homogeneous. So now we can go for independent samples t-test. So write t-test data external. Our categorical variable is gender. Alternative is two-sided. Two-sided. Confidence level is equal to 0.95. Now we need to inform the R that the variances are equal. So therefore we write variances dot equal is equal to 2. That is T. This is our command to perform independent samples t-test. So click on run. You can see two sample t-test is written. So independent sample t-test is also known as two samples t-test because we have two different samples. Our t-value is minus 0.81554. Degree of freedom is 28. So here we have n1 plus n2 minus 2. That is our degree of freedom. So we have 15 male students, 15 female students. So it is 15 plus 15, 30 minus 2, that is 28. So 28 is our degree of freedom in this case. The p-value is 0.4216. Now what is our null hypothesis? The mean marks of male and female students are not significantly different from each other. An alternative hypothesis is there is a significant difference between the marks of male and female students. So you can see the alternative hypothesis is written, the two difference in means is not equal to 0, which means that they are different. Since this p-value is higher than 0.05, we fail to reject the null hypothesis. And we conclude that there is no significant difference in the marks of male and female students. You can see the mean in group F, that is the mean marks of female students, is 39.06667, and mean marks of male students is 43.06667. So that shows no significant difference. So this is how we can perform the two sample t-test or independent samples t-test in our studio. Let me take some questions. If we have more than two sections, we selected one section purposefully, sir. See, if we have more than two samples, we cannot use t-test. We can use one-way ANOVA. So if you have more than two groups, suppose you, in this case, let me show you the data. Suppose we have three groups in faculty, arts, commerce, and science, and you want to know the main differences between arts, commerce, and science students. So in that case, we use one-way ANOVA. who is introduced t-test? T-test was introduced by Gossett, as I discussed in the very beginning. You can see here. William Seeley Gossett introduced the t-statistic or t-test under the pseudonym of student, and that is why this test is known as student t-test. One question is from Smriti. Independent t-test is one variable, be numerical, and one is categorical variable. See, we have one continuous variable. Suppose in our example, we have the external marks. Let me show you the data. So here we have this external marks. You can see this ext common. And then we want to compare whether these marks are significantly different between the categories. So male and female. So one is nominal variable having only two categories. And we want to show or we want to test whether these categories are different from each other in terms of our continuous dependent variable. If possible, kindly provide this R console and data file. It is useful us for practice. Yeah, I'll share the CSV file on our Telegram channel. You all have, I think, received the mail regarding the Telegram channel. So kindly join the Telegram channel. I will share the data file on it so you can do the practice by yourself. Now, if both the variables are numerical, then see if your both variables are numerical, how can you bifurcate the variables according to the category? Here my one variable is gender, that is why I have two categories. But suppose I have internal and external marks, then we don't have two categories. So there is no reason to use independent samples t-test. So if we have two categories or two independent groups, then we can use independent samples t-test. I think I have cleared your doubts, Smriti. Anyone, if you have the doubts, you can write in the live chat box. We are also going to organize a certificate course on research methodology and data analysis using Excel, SPSS, and RStudio. So you can find the brochure on our Facebook page, Crack Economics and Statistics. If you are interested, you can register yourself. That will be a certificate course. So you will get the certificate and join our WhatsApp group, join our Telegram channel or Facebook page or group to get the notifications about our new videos and webinars. Thank you everyone for joining this session. Kindly subscribe to our YouTube channel, Crack Economics and Statistics, and also like and share this link with your friends. Thank you everyone.